Hello, my name is John Sayer, Technical Readiness Manager, Civil Infrastructure here at Autodesk. Today I'll be taking you through a part of the drone to design workflow that we've put together for you. In this video, we will be talking about using the surface from InfraWorks 360 in Civil 3D. So let's get started. When we left off in the last video, we had just created a surface from our point cloud inside of InfraWorks 360. So now we want to bring that surface into Civil 3D and start to use it for preliminary design. So in order to do that, we need to go ahead and close InfraWorks 360. We will bring up a brand new drawing here in Civil 3D. So the first thing we're going to do is we're going to set the coordinate system in our drawing. So in this particular case, that is Arkansas and the Harn. So we'll go ahead and make sure it's set to the Harn. US foot, hit apply, and OK. And this will match the data set that you will receive with this set of videos. So the next thing we do is simply bring in our InfraWorks 360 model and start to extract some information. You'll find that all of the InfraWorks 360 models that you have saved to your local machine, unless you have changed the path, the default path is underneath your username, and then you go to Documents and Autodesk InfraWorks Models, and drop down. I know that this is the last one. These are all numbered. Once you get into the numbered file, you can see what the actual name of the model is. So new residential sub was the name of our model. All right, and I want to refine the selection set to come in. We're going to keep it simple for this demonstration. You could bring in everything inside of the InfraWorks 360 model, meaning the roads, the terrain surfaces for the roads, the actual existing ground information, that's the overall surface. You'll see in a minute that there's actually two different surfaces. One is transportation, called transportation. That would be the road surfaces. So again, you can see that here, existing transportation surface and our existing ground surface for InfraWorks. So I'm going to collapse those trees. I don't want to bring in the roads or the water surface or the water areas. I only want to bring in the InfraWorks existing ground surface. So I go ahead and select Open Model, and it's going to import that surface. This is the surface that we generated from the point cloud inside of InfraWorks 360. So it's molded it together with the model builder surface. So we got to kind of trim that down a little. All right, and it does, the contours do look jagged, and I'm going to explain why here in just a second. So first thing we'll do is I'll look at my surface, and there's no boundary. So I'm going to actually just add a boundary real quick, just a rectangular boundary, so we're not simplifying here in a minute all of this surface. So I'll go ahead and add that boundary as an outer boundary, and the boundary is going to show just the amount of surface we want to look at. So this surface looks a little bit strange. The contours look a little strange, and that's because of all the points that are in this surface. So if I was to look at this surface and look at the surface properties, you can see here under statistics that there's just a few points that are in this surface. There's 446,000 points. That is why you're getting these jagged contours. We can do what's called simplify the surface, and these contours will be more desirable. Now it does take a couple iterations of this to get these down, but I'm going to show you that process right now. So if I select that surface, I can go up and I can select Edit Surface, drop down, and hit Simplify. Now there's a couple different ways that we can simplify this. We can do it by edge contraction or point removal. We're going to use point removal. We're going to select a region, so I'm going to pick the region in the drawing. And what I'll do is I'll draw a polygon. All right, so I'm going to draw a polygon right in here. This is really all the surface that I'm concerned with at this point. So I will simplify this, and I'll close it and select it. All right, so there's 285,000 points in that window. If I hit next, I now can control what percentage of the points are going to be removed. So I'm going to move this up to, say, 95. All right, because I know that a traditionally surveyed piece of ground like this, the actual survey, there's probably around 12 to 1,500 points that's being triangulated against. So you can see at 285,000, that's why we're getting the jagged contours. So I'm going to make my maximum elevation range to start. Let's make that 0.25 and hit apply. And it's going to start the process here. Once it simplifies the surface, it'll tell us how many points are going to be removed. Now, because there are so many points in this surface, it does take just a little bit for it to simplify this surface. It's telling us that it's going to remove 270,000 points. That leaves us 14,000. That's still a lot of points, but we're going to go ahead and hit finish, and it's going to go ahead and simplify that surface, and we're going to get to see a result and see the contours change. So you can see that the jagged edges are still there, but it's a lot better than it was, and that's because of the point simplification process. Again, I told you it was a little bit of an iterative process, so let's go ahead and simplify it again. I'll pick my region again, all right, and we will start here and we'll just move around. Again, I'm just worried, right now I'm just thinking about this field. And I'll hit next. And again, there's 12,000 points in that area, so let's remove 95% of those again. And let's see if we leave this maximum elevation change alone. Matter of fact, let's move it up to a ½ foot and hit apply. So it's going to go through the simplification process again. So again, this could take a couple minutes. Total points to be removed is 10,000. All right, so we've got about the right amount. So let's see what kind of contours this gives us. So we'll hit finish. So those contours look more like what a traditional contour would look like. We still have some jagged edges, but again, remember, we're using this surface for preliminary design, and this will be much better than any DEM information or anything like that that's presented by USGS. We can actually do takeoffs from this information to give people an idea as to how much money they're going to spend on the project. And sometimes you have to do that so that we can win work. With a little bit of tweaking, we can bring that surface in from InfraWorks 360, and we can generate a nice surface for preliminary design inside of Civil3D. Now there's another process to create what's called a bare earth topo, and that includes using Recap 360, the desktop version, and that process will be shown in a later video. Now, I also showed you in InfraWorks 360 in the previous video how we could utilize the georeference TIFF that's generated in Recap 360 so that we could see what is actually out on the site as soon as today. So we can utilize that same image inside of Civil3D also. So we're going to do that utilizing the raster tools or raster design. So I'm going to go up, I'm going to pick raster tools and select insert. And I've got my mesh ortho that I can select. I'll go ahead and select it. That's going to be my georeference TIFF. Hit open. All right, and it comes right in and sits right on top of my area because it's reading the coordinate system of the drawing. So I can just hit next here and look at the correlation values. Hit next. This is the key page here. We need to be sure that the image coordinate system is showing up correctly, and it is. It's showing up WGS 84, and then it's going to show what our coordinate system is that it's going to transform to. Be sure to your transform type is set to true, pixel by pixel. Hit next, and then always look at your insertion point. If this doesn't look like your coordinate system, all right, and you can see the coordinate system right down here, then you know that there's a problem. But if you bring it in this manner, it should work every time. Go ahead and hit finish. What it's going to do is it's going to transform that image to our model here in Civil3D. And this might take just a little bit. So you can see here, after it's through processing, we have the actual ortho image that was generated from Recap 360 whenever it generated the point cloud right underneath our model in Civil3D. And this is an accurate image of what is out there today. So if you think about the products that we used in these last 3 videos, we started off in Recap 360 and generated our cloud. We brought it into Autodesk Remake to look at the mesh to see if everything was looking okay. Then we brought the point cloud into InfraWorks 360 and the georeference TIFF into InfraWorks 360 and generated a terrain surface in InfraWorks 360. Then we jumped into Civil3D and imported the surface from InfraWorks 360, and then imported the same georeference TIFF that we brought in InfraWorks 360 that was generated in Recap 360. Definitely using a lot of the products that are inside of the collection. I thank you for taking the time to watch this video and hope that it's helped you. Have a great day.